you're interested, it's in the book. But there are infinitely many prime numbers has been proved to be true. There are infinitely many primes. That's kind of interesting.
Hey, is this right?
And
It's not right.
the
Yeah.
largest known prime number is 2 to the 403 million.
Why do we really need to know this?
Wait, no, 43 million, sorry. 43,112,609 minus 1. Which is almost 13 million digits long.
Do I need to know this? Like, should I write this?
No, you don't have to know.
Wait, why can't it be 2 to the 99 trillion minus 1?
This is the largest known
Because
prime.
yesterday we had the diversity thing, 2 days ago, just Anna was
The largest one that...
like she just on top of the pile.
Wait, no, not necessarily.
No, we don't know that, do
She
we?
doesn't actually forgets to
Wait, what don't we know?
So,
Why do we not know that?
this number was discovered in August of 2008. This number here is almost 13 million digits long. There is not enough time in the universe. The universe has not been old enough to be able to test all of the possibilities to see if this is prime.
We don't know if that's prime.
There's not. The universe is not old enough to test all of these digits to see if this is prime. Well, hold on for a second.
When you have a supercomputer or a brain
So
like myself,
when the Big Bang happened,
you
you
do that
couldn't.
like
There's
5
not enough
seconds.
time since the Big Bang happened to be able to see all of this, even with the best supercomputer. So there are techniques that they use to be able to test to see if this is prime, to cut down on the amount of time that it takes. And we're going to talk about those. But it's kind of interesting to think that number is that big.
But I'm not. That's the thing.
He's over there now.
All right.
What's the problem here?
Every
Probably going on.
integer
Kind of a lot of stuff that we were saying.
and whoa.
Can you really cut?
Every integer n is either prime or has a prime factor, or prime factors, whatever. Every number is either prime or has a prime factor. Every integer that's bigger than 1. Second thing we're going to use, factor search theorem. Whoa. Factor search theorem. This one's more interesting. An integer is prime. No, let's see this.
Don't say an integer is prime again.
Alright. If an integer has no prime factors between 0 and, we should say, an integer n, square root of n, then it is prime.
Wait, is that supposed to be and between 0 and 1? Okay. Forget that.
I do. Okay, so if an integer n has no prime factors between 0 and the square root of n, then it is prime.
Vicky's lessons are really like disconnected.
There are connections, but they're not real obvious, I think. Okay,
Like the references I'm trying to make.
I know.
What your analogy is?
Okay, why does this work? Well, let's take the number 24 and break it down into its factors.
26.
Okay, we've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6.
An analogy.
Now,
These lessons are really
you right now would probably just test all of the numbers between 1 and 24
Thanks for playing with it.
It was
to
fun.
see if this is prime.
Props.
It's not.
Well, the odd ones.
Actually, no, I would divide by 2 first.
The odd
Two.
ones?
Two.
6 is the fact.
No, you test the odd ones to see if they're prime.
2, 3, 5,
Why can
7.
16 be prime? Well, it's not.
Oh, yeah. I see what you're saying. Okay, alright. Whatever. Some number. Right now, if I give you the number 2,731 to test to see if this would be prime, you're going to test all of the numbers between 1 and 2,731, non-inclusive, to see if any of the factors work. Right? That's going to take a long time. So instead of doing that, we've got the factor search theorem. The factor search theorem says every factor has a pair.
You ripped it.
There's always a pair here. 1 is paired with 24, 2 with 12, 3 with 8, and 4 with 6.
It's a rainbow.
I mean, I was just trying to put in keyword key.
Notice, if you can find just one half,
Maybe it's that one now.
if you can find just one half of these, you will find the pair. For example, if you take 24 divided by 4, you will get 6 out. So you don't have to test 4 and 6, you just need to test 4. What is the square root of 24? About?
4 point something.
That's the flame.
4.8-ish, probably? Something like that. It's a little bit less than 5. So the largest number you would have to test, square root of 24 is, I don't know, I think it's 4.8 something. 8, 9. Okay. So the largest number you'd have to test would be 4. You have to test the numbers 1 through 4. Look at that. All the rest of them will be given to you. And that's that split that we have here.
Interesting.
Because
Okay, this is weird.
the square root of 24 times the square root of 24 gives you 24.
Yes, it does.
So you need to test anything up to that square root, and it'll automatically give you whatever's on the other side. Okay. So what is the largest number needed test to see if 219, how about, is prime?
14.
Go ahead. Just guessing that or yes or no? I got 4.5.
So, what is the largest number you need to test to see if 219 is prime? What are you doing? Square root of 219 is about 14 point something. What was it? 7.9. So 14 would be that largest number that you have to test, the largest integer value. Anything bigger than 14 will be paired with anything bigger than 14.8 will be paired with anything less than 14.8. So you don't have to test that whole other side. Sure. And that makes it a lot easier. So you have to test just 2 through 14. That cuts down a lot of work. Not do even numbers?
Well, yeah. Like if something is specified 2, and then not specified 4, 6, or 8.
If something is divisible by 2,
It's not.
if it's not divisible by 2, then what?
Then would it not also
What's your hair turned blonde?
It's gray.
Gray.
Uh,
Aaron Landgrass already put on this one.
So any other odd number could be right?
Is it divisible by an even number?
No.
I saw him half a few days.
No, right?
Yeah, why do you guys like fruit after school?
Right.
Well, yesterday, Tuesdays and Thursdays, Sarah, Bridget, Sam, and I.
Alright, and I think 3 times 73 is 219. Is that right? So no, not prime. I think 3 times 73 is that. We tested 3, found that its partner was 73.
Why
And
did you do 2 minus 14? Oh, okay.
okay, so that cuts down on a lot of work.
It's not prime?
It's not. 3 times 73 is 219.
All right, I would like to take a number.
A prime number that you can only divide by 291.
How about let's do a standard prime factorization of 60. All right, this is standard prime factorization of 60. All you're going to do is do your factor tree with 60, like you've done for years. So we're going to take 60,
I haven't done anything for years.
break it down into components. Now, if you didn't know if this was prime or not, you'd have to do a little testing, but obviously we know it's not. It's an even number, and you also know factors. So what are some factors here?
2 and 30.
160, 230.
Sure, how about 30 and 2? Now, when we're doing a prime factorization, every single factor that we're going to get is prime at the end. 2, is that prime?
Yeah.
30 can be broken down 15 and 2, I heard. Leave the 2 alone. 15, can we break that down?
3 and 5.
5 and 3. Anything else we can do?
Nope.
Nope, yes, I'm prime.
5, 3, 2, and 2 are all prime, right?
Prime with it.
Here's how we write this, the standard prime factorization. This is technical, but you need to know how to do this. You're going to write the lowest prime first, which is
2.
2. How many of them are there?
2.
2 squared. It's 2 times 2, so you have 2 squared. Then
3.
3, and then 5. That's the standard prime factorization. It always has to go, so you have to order primes from least to greatest. And place exponents when needed. All the numbers need to be prime in there too.
So would you say that's the Optimus prime? Got that.
By the way, if this were 3 to the 15th, it doesn't matter. You just always go by the base. 2 to the whatever, 3 to the whatever, 5 to the whatever. The bases are what you have to order. Everything else you just have to put as exponents.
So what are those numbers?
This, 2 squared times 3 times 5 gives you 60.
Yeah, so
That's the standard prime factorization. We broke it down into its parts of primes. That's it.
Video day.
Mac, did you have a question? Alright.
Yeah, how much?
Alright,
How
the
much?
last thing here before the proof.
Oh. Is this hard? Dude, should this be on here?
You maybe.
Oh.
You can do a prime standard prime factorization. The only thing I'm worried you're gonna forget is to